Dear student, this is a type of problem on in general bearing. So this is not design. This is a small problem, and also it is asked in previous year examination, video previous examination, 14 and 15. So here, we need to determine the power loss. Usually the power will be lost due to friction in general bearing, right? Yes. For a Petrov bearing, so usually while finding out mu, we are going to use either Petrov or Mekis, right? Here he is specifically asked use Petrov bearing, okay? Petrov equation for determining mu, okay? So bearing 100 mm in diameter, okay? So diameter of the bearing is 100 mm. Bearing 100 mm. So in meter it is 0.1 meter, and length is 150 long. Length 150 mm long. So in meters it is 0.15 meter. The radial clearance is 0.05 mm. This is not diametric clearance. If it is diametric clearance, we say see, this is radial. See, half of the diametric clearance is given, but I need diametric clearance. Here it is radial clearance is given, right? So in meter it should be 0.05 into 10 power minus 3 meter. If you want diameter clearance 2 times CR, right? So if you multiply it by 2, you get 0.05 minus 2, 1 into 10 power minus 4 into 10 power minus 4 meter. Speed of the journal is 1000 rpm, okay? N is 1000 rpm. It should be n dash, right? It has to be n dash. So n dash means it should be in rps. 1000 by 60. 1000 by 60 is 16.667 rps. And the lubricating oil is SAE 10. The grade of oil is given SAE 10. So grade of oil is SAE 10. SAE 10 is given. And operating temperature is given. T0 is 60 degree centigrade. Okay. So what is the use of this SAE 10? By using this SAE 10, we can check the grade, whether it is A, B, C grade, right? So from figure 24.1, we can go for SAE 10 and check the grade. This is figure 24.1. Our grade is SAE 10, and what is the number? B grade, B oil. It is B oil. What is the use of this B oil? Okay. With the help of this B and operating temperature, we can get the viscosity. From figure 24.2 for B and T0 operating temperature, we can check the viscosity of this particular oil. This is figure 24.2. Our operating temperature is 60, right? And for B oil, this is B oil, right? Here we are having B, A, B, C, D. Okay, 60 degree B oil. Okay, so just below the 15, almost 14, right? What is the viscosity of oil? 14 centipoise. 14 Cp or 14 to 10 power minus 3 passes. What is our aim in this problem? Determine the power loss, okay, due to friction, right? Power loss, obviously power loss due to friction. What is the formula to find the power loss? N mu. N mu is equal to mu W V watts. If you want in watts, okay. If you want in kilowatts, divided by 1000, right? What is W? PLD, okay. So P is unknown, okay. L is known, D is known, and V we can get V is equal to pi d n by 60, right? Or pi d n dash. What are mu and W? W is PLD, okay. P is still unknown. Mu, yes, we have two equation to find out mu. One is Mekis and one other one is Petrov. Here he has specifically mentioned Petrov bearing, so you have to use Petrov equation. So Petrov equation to find out mu, we have Petrov equation 2 pi square mu n dash p 1 by psi square. Whatever psi is C by d, diametric clearance by diameter. Yes, and the diametric clearance already we found 1 in 10 power minus 4, and whatever d is 0.1 meter. Okay, p is still unknown. No worries, no, don't worry about this p. Okay, we can cancel each other, okay, in the while calculating. So no worry about the, don't worry about the p. So viscosity already found from figure 24.2, and n dash already found, that is 16.67. Okay, so first find out mu. This is coefficient of viscosity. Find out the coefficient of viscosity, we can substitute, right, in n mu. Then we can easily find out power loss due to friction. Okay, substitute all the values. Mu is equal to pi square. So mu is substituted, n dash substituted. Okay, what about psi? 1 in 10 power minus 4, 0.1. If you find out, calculate it, you will get 10 power minus 3, that is 1 power 10 power minus 3. After the substitution and calculation, you get 4605.9 divided by p. Still it is p is unknown. Okay, we will get the value of mu in terms of p only. Power loss due to friction is n mu is equal to mu w v. V is pi d n dash. In place of mu I can substitute 4605.9 pi p, and in place of w I can substitute pld. I can substitute p. L is what is 0.15, and d is 0.1. Substitute 0.15 into 0.1. Okay, into v is pi d n dash. I can substitute pi d n dash. Pi d is 0.1. N dash is 16.667. Now the job is easy. PP get cancel. Okay, now we can calculate. After substitution and calculation, we get n mu is 361.75 watts. Thank you.